Former
Hello, my name is Tim
Falmouth.
Martin from the Falmouth Genealogical Society, and it's some Thursday, early Thursday now in November. We postponed to this, have our last talk on this day. So here we are. And this is for the Joy of Learning series sponsored by the Falmouth Public Library. And we've done 4 talks, or 3. This is the 4th talk now on kind of, we called it Let's Do Genealogy. So this is class number 4. And just be sure you all know that as Clyde is in the Zoom session, do pick up the PDF, please, that there's lots of useful Zoom or lots of links to click on there. So I will start to share my screen here. Oh, I have to start the PowerPoint. Slideshow from the beginning. So this is the Let's Do Genealogy class number 4. And to the first slide, here's the outline for the talk. This is my hope for where we're going. First, types of DNA tests available for genetic genealogy. There's autosomal DNA, Y-DNA, mtDNA, or mitochondrial DNA, and then xDNA. X and Y's go together on chromosome 23. And you'll find out here the xDNA is, yeah, I'll save that. Testing companies we'll also talk about for genetic genealogy, and we're going to discuss AncestryDNA 23andMe, Family Tree DNA, and MyHeritage. And we're also going to talk about a few different genetic genealogy support websites. One of them is GEDmatch, another is DNAPainter. And then also I want you to be aware of a great resource with the International Society of Genetic Genealogists. You should know about that one, and you'll see it briefly. We'll look at identifying DNA matches. We'll look at identifying or placing mystery individuals, and we'll do a short, I'll just show you a little case study from a match that I had. And so here's our first slide. We're talking about autosomal DNA. I like sometimes when to need to be specific and put that AT in front of there. But when people talk about DNA tests, they actually are normally talking about the autosomal DNA test, just for you to know. This is the type of DNA test that all these different companies generally will perform for you. And one of the results of having one of these tests that you'll see first is things like ethnicity estimates. And I'm not going to dwell at all on, just for the sake of time, I'm not going to dwell at all on ethnicity estimates for this talk. But basically what I'm going to say is, it's difficult for these companies, and each company has slightly different approaches, and they some cases use different what they call reference populations. When you say someone is Italian or Sicilian or German or whatever, different regional things, you have to cook up this reference population and then compare your DNA results with that. And so it is kind of fuzzy. And so some people, when they look at their ethnicity results, are kind of confused in some cases, and so then they kind of feel like maybe their DNA test didn't do much good. And they forget to look at the part that really is good. And I just want to emphasize that though your ethnicity estimates are a fuzzy science that varies, and they do update them, and they define different regions and so forth, your DNA matches, that is who you share DNA with, really is definitive. And that's what we're going to talk about. And one way of expressing this that's kind of shocking when you think about it is all of your autosomal DNA matches are in your tree. You are related to them. And I don't know if any of you have done tests, like go with one of the major players like Ancestry.com, and you might see, 1,000 matches, say. That's not unusual at all. Guess what? You are related to all of them. Anyway, so there's a lot of work potentially that you could do. And so I'm just summarizing here. These autosomal tests from different providers are roughly $100 each as you look around. Many times coming a little bit lower than that, but just be aware that the price is less during a sale. And you will find sales that are like 3 or 4 times a year sometimes for these different vendors. So autosomal DNA concerns the 22 chromosome pairs that are generally when inherited, from parents to children. These chromosomes are busted up into varying segments, and that sent off then to the children. And in fact, you do get one chromosome from your father for each of these 22, and another from your mother. So in fact, in that sense, you get exactly 50% from your mother and exactly 50% from your father. But just be aware that a segment that your brother may get may be different than what you get, or so forth. So each of these unique children, not twins, we're not talking twins here, each of these children, one child may have that segment from that German great-grandfather and another may not. So all of your siblings, you will have different ethnicity estimates because of this. You each get different mix of autosomal DNA from your parents. And in each generation, it halves. So you get 50, but then one thing that I'm not going to take much time here for it all is to say, you don't get exactly 25% from your grandparents, or don't get 1/4 of that from each great-grandparent. Is the way things shuffle around and bust up like that. I don't know if you can conceive it in your mind right now, but just be aware that, that's, for instance, why it could end up that one kid would have none of that German segment and another could. So you get different percentages from each of your earlier ancestors. So another concept here that is that shared DNA amounts are measured in something called centimorgans. And I don't think there's a real need. You can, if you click incidentally, all these things here, if I hover over like this, see, if I hover over it, it says it's a YouTube video. So in many cases, I have things that for you, if you ever want to ask more questions about any of these, look at these links, and I have directed you to pointers with more information. So I'm going to breeze through a lot of this and hope that if you're interested in something, you click on the link. If you want to know more about what a centimorgan is, you can look it up here. So, so ask yourself, with all this, with relatives that go back in time, the amount of DNA that you receive diminishes from those more distant relatives. So one of the basic things you need to understand is how often do more distant, boy, I should say that this is misworded. How often do more distant ancestors share ATDNA? Or like if you match, you match with someone in the distant time, how much? Let me show you here. This is useful. We're going to go to a website that shows what your likelihood is of sharing DNA with someone from yay long ago. Like, for instance, first cousins always share DNA 100% of the time, and they always have at least 5 different segments that they share. For first cousin once removed, that is, when one of the relationships is a generation off from first cousin, there again, you always share DNA with a first cousin once removed. You almost always share DNA with a second cousin. See, 99.98% of the time, and you have all the segments, but it's starting to creep in now. Second cousin once, let's go to third cousin. You share not a little over 90% of the time, and sometimes you will get 5 segments and sometimes as little as 1 segment. And here's the one thing I want you to take away and remember, I find is very useful, is simply this little fact, that at the point of fourth cousins is where you have a roughly 50% chance of sharing DNA between you and that fourth cousin. So, and then also notice, you can go out here to seventh cousin. The chances that you share DNA are pretty unlikely, only 1%. However, there's a countervailing factor here. Guess what? You likely have many more seventh cousins than you do fourth cousins, if you think about it. So what that means is that, you understand what it means. You actually do get seventh cousins. Even though the likelihood is small, you will see seventh cousin matches simply because there usually are a lot of them. All right, so that's that topic. And so here's an ISOG link, which is, I think, would be nice for you to see. Also, be aware that I'll real quickly visit this. ISOG has this great chart of all the different companies and a huge number of differences between the company. Like, it's just like average responsiveness of matches, average level of genealogical knowledge of the matches. And so this is a real useful table. Look at it if you're trying to decide which company to test with, for instance. Actually, I'm going to make a suggestion on that anyway. So here's a little summary of when you test with any of these companies, you produce what's called a raw DNA data file. And these raw DNA data files can be, it's your property. You can take them and you can ship them off to other companies, just electronically. You go to their website, and but these two companies here, AncestryDNA and 23andMe, do not take any data imports from others. These also are the two biggest actors in the game. The company with the most testers is Ancestry. The company with the second most testers is 23andMe. Neither of them allow importing any data. But let me just go on. And the case for who you test with, I think, will build up as I talk about it here. So we're going to talk about Y-DNA. We've talked about autosomal DNA. Y-DNA is, some people are men, it turns out. And men on the chromosome number 23 have one X chromosome that they get from their mother and one Y chromosome that they get from their father, and that's what defines them as males. So we're talking about those that have the Y chromosome, in other words, men. And I guess I've said that, but approximately, here's the very important point now. Approximately every few generations, I need to back up and point out this. The Y chromosome, unlike autosomal, is duplicated almost exactly from father to son. It's not busted up into pieces. It's duplicated almost exactly. However, every few generations, a single mutation, that single nucleotide polymorphism, SNP, is how people pronounce it. A single SNP occurs and is passed on to all subsequent generations. And these SNPs then are unique to that male branch henceforth. And that's what's called a haplogroup. So we'll probably say something about haplogroups in the future. And haplogroups are defined by the mutation that occurs that you bear in you. So so all the different haplogroup names are simply names of SNPs or groups of SNPs. There's another kind of mutation that's analyzed in Y-DNA, and that's an STR, a short tandem repeat. And that's where the DNA pattern kind of does a stuttering thing. There's these CTGA, cytosine, I don't know, the different ones, and on the individual alleles at the smallest level of DNA. there'll be kind of a stuttering pattern, and sometimes it'll be like 13 stutters long, and then that stuttering pattern will get passed on to your descendants, but that will mutate. So instead of being a 13, it'll be 12 repeats or 14. But what's different about STRs is they can actually flip back and forth. So it might be 13, go from 12 to 13 in one generation, and then 2 generations later, it'll go right back to 12 from 13. So you can't count on it as a forever marker. But it is useful to use STRs, but SNPs are permanent, and they are used for defining, haplogroup branching. So why DNA is trackable by males? This is the weird or wonderful part. Why DNA is trackable by males on their paternal line through all time, back to, the Y-DNA atom. And you can look at, this is a nice YouTube video that you can look at that explains that. And furthermore, I am going to do this. I'm going to look at this is my most recent, that is the last SNP on my branch, is this 193790 in the higher level R group, R-FT19370. So male, this also does mitochondrial or female. We'll talk about that in a moment. So we say go. So this shows through history where at each of these dots here, there actually remains of individuals from the deep past who were found and analyzed, and they had these mutations. And so the path, and every one of these dots represents someone that I absolutely know I am related to. They have that SNP. It occurred, we don't know who it is, of course, but in someone, this mutation occurred, and it was passed on forever to all their descendants. So if I scroll up here, you can also now look at these SNPs. So that's their geographic, where they went from, most recently. This is, okay, let's go to, if I look at the SNPs here, this gives you a feeling. So way back in time, 232 BCE, there are 227,855 Y-DNA testers who have this SNP. It's very ancient, almost, huge number of people have it. But as mutations occur, fewer and fewer have that. It gets more and more further down the haplotree, and going through time here, you can even click on these dots here and see where did this dig occur, at what location, and it's amazing. And finally you get down towards recent history, and there's 2 people that have this SNP right here, and guess what? It's me and my son. That's who has that one. These 5 here include me and my son and 3 of my cousins. This, and it just goes back in time. So that's wonderful. That gives you a good feeling for the power of Y-DNA to reach back in time. Unlike autosomal DNA, which you just hardly share anything, like 12 generations or so, you're just not going to be able to do any work. So Y-DNA. I'm going to skip over this. This is my Martin group, and this shows where SNPs have occurred and who holds them. And I've decided I don't have time for that. You can look at it maybe. So xDNA is something that's recently come into use. That's, there's a chromosome. A female receives 2 X chromosomes, one from her mother and one from her father, and a male receives 1 X, from the mother and father. But everyone has an X, a woman has 2. And so the main thing we need to know about xDNA, I want to point out, is there's an inheritance pattern that's different for males and females. Let's look at it on a chart. So we're going down here to this website, and they have this handy chart. So if you are a female here you are in this center. This is like a big pedigree tree here with a individual at the center. If you are a female, you receive one X from your father, blue, and and another from your mother, pink. That father here only received his X chromosome from his mother. He didn't get one from his father. And so this results in a pattern through here. So X DNA for a female only comes from these individuals on her pedigree tree, is what we're saying. Look at the inheritance pattern for a male instead. It's narrower, but for a male, he only got his X DNA from his mother, and then she got it from a father and a mother, but there's a limited number of peoples here. So common ancestor for your match will be only someone within these colored pink or blue spots. You see, that's what's going on. All these other people in your pedigree tree are eliminated because you couldn't have gotten an X from them. These are the X's that you could have gotten them from. Okay. Back here, that's xDNA. And also I should say, all the companies, when they test your autosomal DNA, they do get X data, but only 23andMe and Family Tree of DNA and at GEDmatch actually report the xDNA data. So if you get a test at Ancestry and you import the data to GEDmatch, you can look at your X data that way. Ancestry doesn't report X results. That's what I'm saying. Okay, mitochondrial DNA is very similar to Y DNA. However, it is a circular chromosome that's in the cytoplasm of the cell. It's not in the nucleus. The other chromosomes we talked about are in the nucleus. And the interesting thing about mtDNA is it is in much greater abundance in our cells than the 23 nuclear chromosomes. So it is more available in ancient remains. So oftentimes they'll dig up some remains of a person and they'll only be able to get the mtDNA from it because, there's just not enough of the autosomal DNA available. So mtDNA has been the most successful in reaching back in time, I guess is what we'll say. But the difference here is the mtDNA SNP mutation rate is considerably slower than Y DNA. So you can't resolve things through time as well with mtDNA as, or let me put it this way, summarize it this way. With Y DNA, these mutations, SNP mutations occur roughly every 3 generations. That can change radically, but we'll say roughly 3 generations. With mtDNA, I'm not actually, I don't even know what it is. It's a much larger number. So you can't pick apart what's going on in time as easily with mtDNA. Okay, here's a company, AncestryDNA. It has the largest pool. We've talked about types of DNA. Now we're going to talk about companies who actually do tests. AncestryDNA is the largest pool of autosomal testers. As I said, it does not, however, allow importing of DNA data from other companies. So that means if you're desiring, to get a bunch of cousin matches, you should test at Ancestry. They're the biggest company, and you don't want to miss them. Test at Ancestry. Another thing that's very special and useful about Ancestry, I have to point out, is if you upload or create your family tree at Ancestry and then link your DNA matches to individuals in that tree, Ancestry works up something that they call through lines that will feed to you predictions on, see, they have other people's trees with their DNA matches and yours, and they have these trees floating around that they look at, and they will provide you numerous suggestions on other cousin matches that you're not aware of through something called through lines. You just have to be careful that some of that data is based on faulty trees, but I can't tell you how useful and how many matches I have found through lines. So down here is a whole collection of YouTube videos regarding ancestry for your future enjoyment. 23andMe is the second largest pool of DNA testers. And like Ancestry, they do not allow importing of data. So you might also want to test at 23andMe if you need more matches. And here's one of the special things about 23andMe and one of the companies coming up is Ancestry. If you will see the amount of DNA that you share with your matches. That's it. It's so many centimorgans. You share whatever, 800 centimorgans with this first cousin. But if other people share DNA with that first cousin and this is what are called shared in common. Most of the sites call this shared in common. You can't see how much DNA your cousin shared with another one of those matches. And that's a huge source of information, actually, okay? And Ancestry doesn't show that to you. 23andMe does, as well as MyHeritage, I think we'll see here. So that gives you a lot more matches, and especially when you're looking for mystery individuals. See, like if you want to track down what's going on with not yourself, but someone else's DNA, then you need to know how much that person shares with various individuals in addition to you. You want to figure out where they are placed in the tree. They're a mystery individual. And it really helps to have all these other matches. How much DNA do they share with all these other matches? Really helps. 23andMe shows you that. Also, 23andMe has been in the health-related DNA analysis field a long time, and I think they're probably the most successful at that, or they have. So if you like, the health-related, which I'm not going to talk about at all because I hardly pay attention to it myself, 23andMe is good for health-related stuff, apparently. And 23andMe does display xDNA matches, unlike, they display it. And here's a collection of YouTube videos for 23andMe. We'll discuss family tree DNA. It's one of the oldest testers. The thing that's nice or unique about them is they're really the go-to place. If you want Y-DNA or mtDNA testing, you need to go to family tree. So, and remember, I think you should have deduced by now that mitochondrial DNA and Y-DNA are excellent if you are particularly interested in that purely maternal line or the purely paternal line. And, in this male-oriented society, people are interested in surnames a lot. I'm a Martin, and and so I'm working on this Martin Y-DNA group, trying to figure out how all of us Martins from deeper history connect. And, I'm going to spare you all that discussion, but just say it's really interesting. So NFT-DNA also displays xDNA matches. So, here's be aware the mitochondrial DNA and Y-DNA tests are considerably more expensive than the autosomal test. So in that case, you really do want to wait for a sale, but you have to get those two tests here, family tree DNA. MyHeritage, last company I'm going to talk about, I'm saying about them that they support more out of USA testers than the other companies. And that is a true statement. So if you want to cast your net for people who are in Europe or somewhere else, you'll do a good job to go to MyHeritage, or a better job. Also, this is very nice with MyHeritage. One paid account, you pay for membership. It's not nearly as expensive as Ancestry. One paid account allows importing and analysis of multiple DNA kits. So you can, like, if you start, be the go-to point in your family for helping everyone else with their DNA or something, MyHeritage is really nice for just managing all their results and keeping track of what's going on. So MyHeritage also allows you to see, yeah, it's another one of those cases where you can see how much your DNA matches share with each other, not only you, but others. That's really powerful recall, as what I've said. And they have an excellent collection of DNA analysis tools. There's also a tree consistency checker that's really nice. Let me quickly show you auto clustering. This is I'm going to show you the auto cluster feature from MyHeritage. Let me first explain it. So MyHeritage and turns out GEDmatch too, you'll see, does auto clustering automatically, where it'll group all of your matches into their common, if they share DNA with each other, if a bunch of people share DNA with each other on the same segments, that's the catch. If they share DNA with each other on the same segments, all those people have the same common ancestor. They all got that. That little piece is characteristic to a couple. And so all those people have that same set of common ancestors. And so auto clustering automates this. Okay, I'm going to click on it. Here we go. And so this is my DNA kit at MyHeritage. So it automatically, oh golly, I guess I got to zoom in? No, I can't zoom in here. I'm sorry, folks, but let me just say, these are all individuals from left to right, and the same individuals. It's just like a plot here. So this is a whole bunch of individuals that share DNA with each other. And so, like, for instance, if you've already figured out that 2 of these come from your triple great grandfather, then in fact, that all these others are also you are in common with them. So it's amazing. It's a nice feature to help you through as you get matches, you can start figuring out where they lie after you've figured out some matches first. And you can use auto clusters for that purpose. Okay, GEDmatch. Now they don't do DNA testing, but they're a really good site for analyzing. They will take imports from every site, and it's very cheap. You can have free membership. You can do a lot of things for free, and you can do even more things for very little additional money. So this is GEDmatch. Remember, you see there's a link here, so you can go to GEDmatch by just clicking here. And I don't know how many of these I'm even going to mention. Here's a weird one, or an interesting one, very helpful. Here's a tool that they called Lazarus. Lazarus was raised from the dead in the Bible, you recall. Well, like for instance, I've had all of my siblings, they all have different DNA from the past than I do. I mean, some of it is the same, but some of it's different. So if I want a better picture of the DNA that my father had, he's deceased, and my mother's deceased, I can put together a very good representation of my father's DNA and my mother's DNA by collecting the DNA of all my siblings and having the Lazarus tool throw it up in the right place, right segment, so I can reconstruct the majority of the DNA from my dad and the majority of the DNA from my mom. And that actually helps. Maybe I won't go through the logic for you now, but people are working on even extending this back into earlier generations. Some people say that as the science develops, it's going to be possible to reconstruct the DNA from individuals quite, in the right cases where you have enough testers to support it, you'd be able to, reconstruct the DNA for someone quite long ago. And that's being developed. So that's GEDmatch. So Identifying DNA matches is one of the things you want to do. So the first thing you do is start properly placing your known DNA matches. What I mean by placing them is placing them in a tree. So if you know, if you find a match, say it's a first cousin, you know how you relate to him. And so you put that in the tree and you tag it on what side you are that handles these DNA relationships. So that's the first thing. Deal with your matches where you know where they lie. And then there's something called the Leeds method, which is really very helpful. And that is basically to figure out for all your matches, which grandparent they have DNA from. Now, if you think about it, you and your siblings all, so this is not an exercise that helps with your close relatives. This really helps figuring out your more distant relatives. So, and in fact, see your first cousins, right? A first cousin will have DNA from 2 grandparents. So what you want to do is take all your matches that are less than roughly this threshold. At that point, you are dealing with, second or third cousins or less. Now, be aware, you can have you can have a first cousin that's twice removed who will have a low number like this, but that first cousin will show up as sharing DNA with both grandparents. So you just basically have to be a little careful with the Leeds method, just to be aware that some individuals will have these low amounts of DNA, and you just need to check and see, do they share with descendants of this grandparent and that grandparent or not? And so you can, in fact, assign these, what I'll call intermediate level matches that represent second and third and fourth cousins. You can assign them to a different grandparent. And that helps hugely from then on for you, like if you say get a mystery match, you can immediately figure out, well, which grandparent's line do I need to work at in order to find out where that mystery match is. So I've already discussed auto clustering tools. So your goals and what you want to do with your DNA may dictate whether you should test it more than one company. And I think what you'll find is it's often true that there's a lot of problems you can't solve with just one company. And so, as you get into this, I think what you'll find is it really does help to, when you can, to test it more than one company. So some of the things you can do, you want to find new cousins and identify and place unknown matches. Be aware that some matches may reveal a misattributed parental event, an MPE. And here's some of the red flags for that, or at least this is not always true, but these are indicators that beware, maybe this is an MPE. Say you have a close match and their tree conflicts from yours at some important point. I mean, you just got to say, well, one or the other, or maybe both might be wrong, because so that's a red flag. Or one thing I found is that, some people will have post their DNA results and they will post a tree, but then for some reason you look at it and they don't have anything, their mother, there's no ancestors for their mother. And oftentimes I'm finding the reason that's true is because they don't know who their mother's parents are. And there may be an MPE there. So when you find these missing branches in other people's trees, your matches, that's another indicator of an MPE. Things you can do now with these DNA tests are finding your biological parents, or say finding your biological father, or both parents, like in a case of an adoptee. There's all kinds of examples here. Or say you're wanting to work on your paternal line, where did my Martins come from? Then you'll do some Y-DNA testing. Or you want to find out more about your maternal line. This is more difficult. And so Depending upon what you want to do, you'll do different, in some cases, do different kinds of testing. And another thing here, real important, is you'll find that oftentimes when you're doing DNA that you need to find living people. And here's why. When you're utilizing DNA matches, it is normal to have to build a family tree for the many matches that have no tree. You know, there's just I would say most people who do a DNA test, they're just, who knows, they got it as a gift or something for Christmas or from somebody. They really don't know what to do with their results. They don't know how to post a tree. They've abandoned interest in signing into the count. You're sending messages to them and you don't even get any feedback. So guess what? In many cases, you're going to have to figure out who they are and build that tree yourself. And so that's one very common reason. And so, you know, that's a whole nother topic on how you figure out who this person is. They have like a coded name or initials or something, but there's no end of clues that are possible. Well, here's another reason. When proving a mystery connection, you may need to ask an individual, a living individual, to do a DNA test for you. That's another reason you need to, you know, find living people. You're working on a tree, you're wondering, well, where in this tree does this mystery individual lie? And you're not quite sure, you know, well, there's these 3 brothers there, and I'm not sure which brother was the father. That kind of thing you can't, in general, know unless somebody does a DNA test in there. And so you have to find out, well, what are the names of these brothers? How do I contact them? Well, you know, here's some services that I use that are good examples, but also I can't tell you, and I'll show you an example right away here of how like Facebook is excellent at finding living people through clues too. So I want to show you the DNAPainter website. Here's this tool is very helpful, the shared centimorgan project. So this shows how much DNA is shared for different kinds of relationships. For instance, if for first cousins, they share on average 866. I don't know if you're able to read this. I'm going to read it for you. But there's a number here in the middle. A first cousin on average shares, or first cousins on average share 866 centimorgans, as little as 396, and as much as 1397. And if you click on this box, you can see the actual histogram or distribution. So by the time you're out to 1400 centimorgans, first cousins, it's very unusual for, you know, it's more unusual for first cousins to share that much DNA, or for first cousins to share 500 centimorgans. That's pretty unusual. And so what you can do, for instance, and you'll see is the main takeaway from this I want you to know is for the closer relationships, you know, first cousins, and like if you compare first cousin, first remove, you'll see there's not much overlap between these distributions. So what that means is you can often distinguish a first cousin match from a first cousin once removed match just by the amount of DNA that they share. And you can look at these distributions, or one other thing on this, come on, go away. There you go. At the top of this, suppose you share 400 centimorgans. You can just, whenever you get a match, you can go to this page, say you share 423 centimorgans. It will show you the probability of your relationship. You know, you share 423, and there's an 80% chance that you're one of these relationships, 20% here. And realize, see, the great aunt is very different in history. There's you know, like 3 generations there compared with someone who's, you know, say a half first cousin or something. So it looks daunting here, like, golly, look at all these relationships. How do I know which one it is? And you'll find in most cases, you'll be able to know through logic, like, you know, their birth date, and, you know, it's things like this. And you can make guesses of, nah, they can't be a nephew, or, whatever. And so you'll be able to distinguish these different kinds just by some logic and knowing people's birth dates and where they might sit in the tree. But there you go. That's the shared Centimorgan project page. I guess I'll take a quick shot at this. I will show you you can at DNAPainter website. I have had a whole bunch of matches, and I know on what segments I share. And so here's my little chromosome map. On my chromosome 1, I have a paternal chromosome side of number 1 and a maternal side. So for each match, I get a segment from, it's like this green one is Leora and Louisa. Let me see if I can, let me hover over one that's somewhere closer. You see, like here, Grover Manson Mood, that's my grandparent. And so if someone are, here, Jacob, here, this is further back in time. Jacob, Solomon, Crum, Martha. And so if I get another match, and I see that they share this segment with me, I know that we have that common ancestor between us. So that's another way of dealing with mystery matches, is you see which segment they share on it, and you take and you can see where it overlaps with, if you map out many of your matches into this color map here, it'll really help you to figure out where other matches might relate to you. So that's DNAPainter. Okay. Here we go. So this is what we're going to end with, is a case study of someone I'm calling Jane Doe. And we're first going to use conventional logic. And then I'm going to show you at the end a quick, what are the odds WATO tool that helps with much of the conventional logic. And some of this, in the interest of time, I might skip, and you can read this yourself, but I'm going to start reading this to show you how this might go. Jane Doe contacts me on MyHeritage about her 411 centimorgan match with my maternal side first cousin. You see, I manage his kit. I'm that person in my family who manages kits for my relatives. So she sees that match. Turns out Jane also matches me, but she's reached out because of that match first. So I look at that amount, 486, he's a first cousin he's first cousin she also shares with. So that amount suggests that Jane is likely a first cousin once removed to my cousin and myself. That website with the distributions of shared DNA, what was it called? The shared centimorgan project really helps with that. So I can say, Jane is probably my first cousin once removed. And that what that means is, when I look at her age, and in fact, see, I'm pretty old. When it's once removed, she's not like once removed in the sense of older. She's once removed younger down from me, because, I'm pretty old now. So she's probably in the next generation, younger generation from me, once removed. So I'm thinking she's probably the child of one of my first cousins. So Jane also, I see, clearly has DNA from my mother's side of the family. So it's one of my first cousins on my mother's side is who she connects with. So Jane, this is very important. Jane cooperates, asking for help, and she lets me see her matches. Remember me talking about some of these websites, DNA sites allow you to see the matches that others share? That can really fill in. But what's even better than that is when you get a mystery match, having them cooperate and let them just see all of their matches. Okay, so she let me do that. So I sort her matches into the 4 grandparent groups. Jane's matches from one parent. I don't know, when I see matches, you don't know whether some of the matches sometimes are from the mother's or father's side, but you can, where am I here? Yeah, so Jane's matches from one parent are from the mother who raised her. See, I do have her family tree and her matches. And so that all made sense. Say, oh yeah, it looks like your mother, your mother's ancestors are in your match list and their descendants. So looks like your mother is, she's the mother that you think. But matches from her other parent, that is her father, are from my mom's side. In other words, her father seems to have come from my people. So Jane's father appears to be one of my first cousins. And since it's a father we're looking for, her mother is known, we don't know her father. So we're looking for a male first cousin to be her father. But see, she's only tested here at this point through MyHeritage. And the problem is, I'll show you in the next slide. I'll show you in the next slide. But so I ask, we split it up. I say, hey, one of us get a test, I'll pay for the test at Ancestry.com, you pay for the test at 23andMe, and so that's what we did. So she took 2 more tests. We waited for those. So here's some facts on Jane. She was born in 1953. Both of her parents who raised her are deceased. That's part of the reason I'm willing to talk about her, and there are interesting things now. There are 8 siblings in my mom's family. And from those 8 siblings, I have 21 male first cousins on my mother's side. So I have to figure out which one of those 21 males is it. My brother and I are too young, but watch this. There's lots of logic that comes to play. My brother and I are too young to father a child in 1953. And furthermore, if we were the father, we would share much more DNA with Jane. So it's not my mom's branch. Jane's 23andMe results come in, and there's 4 matches that come in through my mom's siblings. That was really helpful. So branches of 5 more of my mom's siblings are ruled out because of all that, because the males are too young to father a child, or 4 of the new DNA matches share too little DNA to indicate fathers in those branches. So we're already eliminating a lot here. In addition, the fact that Jane and I share X DNA says that Jane's father must have a DNA path through a female aunt of mine. That I learned through the X DNA and that chart. And you can, obviously this is, maybe your head is swimming, but you can go over this again. 2 branches of my mother's sisters remain to be investigated for possible DNA matches. One branch has 7 males and the other has 3 males. So now Jane's results from Ancestry come in. The branch with 3 males, however, still has no matches. No testers showed up with that branch of 3 males. 2 of those males of those 3 is old enough to be a possible father. All right. Now there's that other branch with 7 males. And in that case, 2 matches did show up in the Ancestry.com results. And in that branch of 7 males, 4 of them are too young to father Jane. So we're down to 3 now. And the oldest of the 7 males had a granddaughter who tested at Ancestry, and her results show that 442 centimeters DNA is too little to be Jane's niece. In other words, if this guy were Jane's father, then this granddaughter would be a niece. But 442, that's way too little for a niece. So this, I'm just showing you the logic. A daughter of another male in this line shows up with 1096, and that's, you know, yeah, okay. I'm going to go on here. So we're down to 2 males. So one of the 2 likely father candidates who's now deceased, had possible physical proximity. So this is conventional genealogy. Now we figured out, by golly, Jane went down to visit in Chicago frequently, her relatives. And that's where this possible father lived at the time. So maybe he's the one, we don't know. I decide he's deceased. So I contacts the eldest male in the branch, and I decide to only confide in him. I'm not going to blab this to the, all the relatives or anything. I will, and I tell him, I'm only going to talk to you about this, so forth. And so he reports to me, it was interesting. He reported me that his proximate, his brother that was in the area, who's now deceased, did in fact have a surprise child. But this is strange. It was a male who was born in 1958 and known and welcome to the family. He only gives me his name. So what this means is I suggest that a second female child is possible. And I'll just tell you here, my cousin didn't like that idea. So he didn't, So via Facebook and Ben verified, we in fact located the surprise male. We had his name. And, we have some proximity ideas and stuff. So we figured out who he is. And Jane decided, we talked about it. She wrote a handwritten letter to him suggesting the idea that, hey, I'm your half sister, and wouldn't it be nice, what do you think? Is that possible? I actually forget the content of her letter. It was up to her. And so he ultimately was willing to do a sibling test, but he insisted not through any of these mainline DNA companies. He was concerned about privacy and all this sort of stuff. So he actually found for himself a private company called Paternity USA. And so he purchased and managed the kits. He sent 1 kit to Jane and 1 to himself, and he took the test to see if and the test can report whether you're full siblings or half siblings. That's what we wanted to know, a very focused test. So that could be a useful site for some people. So Jane Doe, in fact, tested as being a half sibling. So that branch that we could not resolve, we didn't have to, because this test turned out positive. So Jane, in fact, figured out who her father is. Now, in the remaining few minutes, I'm going to show you how amazingly this WATO tool does everything that I described. So we're going to go to the WATO tool. This is at DNAPainter. Actually, I have to go back to my dashboard. Save trees. Here we go. Jane Doe. Let me explain so what's happened here. I have a tree on Ancestry.com that's where, I have it at home too with Family Tree Maker. But in fact, it was on my Family Tree Maker at home that there's a feature where I can create a GEDcom. That's a format of a Ancestry family tree kind of file format. So I can generate a GEDcom for any arbitrary group of individuals. And in this case, I created a GEDcom for my grandparents who spawned all these 8 children. And I said, create a GEDcom of these grandparents and all of their progeny. So that GEDcom file, I did a load operation. I just clicked load here, and it pulled in the GEDcom. Normally it has all the names, but I've changed it here to a bunch of initials. And it creates this tree. I sent it to tree, and all it does is create this tree. And so down here you can see the grandparent. Where are we? See this? I told you I have I have 31 cousins on this side. And so that's the 31 cousins are in this generation here. Here's the grandparent here. And here's one of the children of the grandparent. So there's 8 children here, up and down, and all their children. So this is this tree, sizable tree, that WATO created immediately. I didn't have to do any work. It created it immediately from the GEDcom that I uploaded. All I have to do is identify the individuals who have taken a DNA test and enter the amount of DNA that they share with Jane. And up at the top here, I label this, I say, target name, Jane Doe X is what I'm calling her here. And I do put in her birth year because computation, this program does do computations relating to, is it reasonable that this person be a father or mother at this age? And that's one of the many things it uses to calculate. So it's important to enter the birth year for the individual. This is the mystery individual. You're wondering, the basic question is, where might Jane Doe fit in my grandparents? These are their initials of the woman and male father pair. Where might she fit in the tree? I know she's somewhere in this tree. I have all these matches that she shares DNA with. I think there's something like 7 matches total here is all I have. So I had all these 7 matches. And here they are. Some of them are children. In fact, only one of these testers was a first cousin. Oh, no, it's 2 of them. I'm looking here. Here, okay, there are 2 of them. Okay, looks like 3 of them are first cousins. I have 3 of my first cousins tested. And as I scan up and down here, some of them are children of my first cousins. That's an example there. But what's fortunate here is I have at least 1 tester from each branch here. Actually, yeah. Actually, that's not true. One of the branches did not test, but so anyway, so this is the data. And the way I do it, I just click enter the match centimorgans, and I could enter like 200 for this individual, and I just say save. That's it. That's all I had to do. I'm going to remove that now. And now we're going to go and click. So I have this tree, I've entered all the data on, and it will in fact look at all these probabilities from the shared centimorgan project, and it will do all the calculations to estimate, where might this person fit? So I click here, suggest hypotheses, and it rapidly comes up with 7 hypotheses. I can actually go to the bottom here and look at those. And it turns out in this case, I can go above, and all these, the higher the score is, means the more likely that is the truth. And in this case, and it ends up different for every run. It's a tie, and what it is, it's a tie between all these siblings in that one branch. But there's some things that WATO doesn't know. Like, for instance, this female branch here, it's not able to, I can rule out some of these. I had to rule out with logic. So in other words, WATO can't do everything for me, but it did confirm for me that it had to be in this branch of males. And so let's go up and look at them here. Where are those? Here's the group. And incidentally, there's different colors here, and just be aware that indicates different parents. So I'm just saying, I guess what I'm saying here is that this WATO tool is great for giving you objective measures of likelihood, and with a little bit of additional logic, you can look at these individuals and rule out, this one, here, this father 1938, golly, he would be 48, he would be 14 years old. So it considered him a possibility, but you know, I say we might ourselves rule that out. So I'm just saying, that's just an example here of just saying that WATO does give these predictions. You also use your head a little bit. This would have been a real young father here, but it turns out that the actual father is this one right here, who's, you know, has been deceased now. So that's it. That's the look at WATO, I think. So I encourage you, and you'll see back in my PowerPoint here, there's lots of links for how to use WATO. It actually is just about as simple as I said. You just create a GEDcom, upload it, put your match data in with the right individuals, and say compute. So where are we? Yeah, so we looked at that WATO tool. So here's my summary of useful links. There's more in the above. Final slide, I'm just saying here, you can get help any Tuesday with us, 2 to 4 p.m. at this library. Also, we have free talks monthly. We have one coming up on November 12th. Go to our website and learn more about it. Also, we're wanting to draw to your attention this wonderful, like once every 2 years, premier local genealogical conferences in Springfield, Mass, with the New England Regional Genealogical Consortium. If you're interested, this would be great to go to, and we'll get to know each other better too. And one thing also I thought you might, how many of you heard about the crack in the case of Lady of the Dunes? Well, it turns out, I looked very soon after that case was cracked. You know, her name was revealed. And so people went, remember how on Family Search, they're building a world tree? I looked at WikiTree. I didn't find anyone working on Ruth Marie Terry there, probably is by now. But a couple of days ago, I looked, and lo and behold, people were working on Ruth Marie Terry and her relationships and so forth. So if you click on this link, you will go to the Family Search, Ruth Marie Terry on the Family Search tree. And you can see there in progress, you look at the dated entries and who enters what, and you can even participate if you want to be involved too. But I thought that was a very interesting thing. Certainly you want to be sensitive to the family who's just finding out about this. And so this should be no encouragement to disturb or bother family members. I just want to throw that caution out. But on the other hand, it very well, this kind of group effort is the kind of thing that's actually required for the detective work. They want people who know stuff in this area to be, provide information. So who knows where they get, how, but that's it.
For those who didn't